Strings can contain code, but in order to interpret that code, you have to be able to parse it first, which means building the tree-structured expression that you can then interpret. Languages with recursive structure are quite common, especially programming languages. Even languages that do not support recursion themselves typically have a recursive structure. What do I mean by that? Well, even the simplest language we've looked at, the calculator language, which was this tiny little subset of Scheme, only had built-in procedures, but it still had a recursive structure. In that, an expression in calculator language was either a number or a call expression, and a call expression is plus minus times divide followed by 0 or more expressions, which have call expressions, which are expressions, which have call expressions. There's the recursive structure. And at this point in the course, when you see a string like this with balanced, properly nested parentheses, you should say, oh, that looks like a tree. In order to write a function that converts this string into a tree-structured expression, we would need to use the kind of tree recursion that we saw when we were learning about the calculator language in the first place. But shouldn't there be a simpler way? Couldn't we write a regular expression that tells us whether something is a properly formed calculator expression or not? Well, part of it is that we need to decide which different characters are allowed in this language, and here's the whole list. But there's more to being a valid calculator program than just containing these characters. It must also have a tree structure with balanced parentheses. That is, every opening parenthesis has to have a closing parenthesis. And as you scan from left to right, there can never be more closing parentheses than there were opening parentheses. The closing ones have to come later. Well, it turns out this last constraint is hard to express using a regular expression. What do regular expressions have to do with this anyway? Well, we're looking at some string and asking whether a pattern exists within that string, where the pattern is, this is a legal calculator program or calculator expression. That's the kind of problem we're trying to solve. We said that regular expressions are a technique for finding patterns in strings, but here's an example of a pattern that's hard to identify using a regular expression. To convince you of this, we'll look at an even simpler language than calculator, the parentheses language. An expression is 0 or more expressions surrounded by, well, these aren't parentheses, they're angle brackets. But they have a left and a right, so we'll think of them as parentheses. And why am I not using parentheses? Well, parentheses are special characters in regular expressions, which means you have to escape them, which makes everything more complicated, so we'll just use angle brackets. Here's the whole definition. This is a legal expression in the parentheses language because it's an expression that is surrounded by angle brackets and has some expressions within it, which are surrounded by angle brackets. So it has one expression within it, and that has more than one expression in it. It has one here, one here, one here, one here, and one here. So 5 different expressions within this expression, which is the one expression within this expression. So this language is like calculator in that it has balanced parentheses. It just doesn't have anything else. So we've gotten to the essence of the problem. How do you write down a regular expression for a pattern that is balanced, properly nested parentheses? I think here's a good place to start. Either it's an angle bracket open or an angle bracket closed, and you need to have at least one of those. Maybe at least 2 would be better. But this is too expressive, because sometimes we get the close before the open, or 2 opens and only 1 close. Neither of those are in the parentheses language. So let's see if we can do better. So here we are back on regex101.com. We would like to write a regular expression that matches these strings, but not these strings. Well, I can match the first one like this. What about the second one? I could say that this is optional. So I got the first 2. Or I could even say that 0 or more of these can appear, and now I have the first 3. How do I get brackets within brackets within brackets? Well, I could say that in this inner one, there are in fact some brackets there, or there aren't. Now I've covered the first four. I still don't have a regular expression that matches the fifth and sixth, but just by repeating this pattern I could get there. Within this set of angled brackets, there could be yet another set of angled brackets. And within that, there could be yet another set of angled brackets. And this regular expression ensures that, in fact, all of these strings that are valid expressions in the parentheses language are matched, and none of these are matched due to various imbalance problems. But the issue is that this only works to a finite depth. If I had an even more deeply nested expression, it wouldn't match anymore. I'd have to extend my regular expression even further. So it turns out that you can balance parentheses as long as you have some limit to the number of nestings that you're allowed to have. But in the case of unlimited nesting, you need an arbitrarily long regular expression to match it. A regular expression for depth 2 matches all the depth 2 variants, but not the depth 3 ones, and extending it to depth 3 gets you all the depth 3 ones, but not the depth 4, and 5 and 6. Regular expressions cannot describe recursive structures of arbitrary depth. That's the problem we're going to try to address today. And it's important because if you want to write something that matches the code in a programming language, you need to be able to support arbitrarily complicated expressions. You never know. Someone might try to write their entire long program as one big expression that has a whole lot of nesting, and it would be unfortunate if your interpreter just gave up after a while. By the way, one consequence of this is that there is no regular expression that describes the set of all valid regular expressions, since the syntax for a regular expression involves balanced parentheses, which can be nested to arbitrary depth.